This video is brought to you by Monoprice, offering you high-quality cables at everyday low prices, all with a lifetime warranty. Monoprice also has adapters, keyboards, headphones, and even gaming monitors. Click the link in the description for more information or visit monoprice.com.
Excellent!
Hey guys, welcome to Paul's Hardware. Today is a very special video because I have a brand new SSD here from Intel. This is the Intel 750 series SSD. First ever NVMe consumer drive available on the market, 1.2 terabytes, just an insanely fast drive, pretty much the fastest drive that you can get right now if you're looking at the consumer side. So to help me talk about this new product from Intel, I have JJ from ASUS.
Yes.
What? JJ's here. Welcome, JJ. Thanks for being here today. JJ, as you guys might know, is Intel's or the ASUS technical marketing manager. We have many names. We call him Dr. ASUS. the Prince of Perspicuity. My newest one.
Thank you. I appreciate
my newest one. But thanks for being here. But why are you here, JJ? What does ASUS have to do with this new Intel SSD?
You know, pretty much this actually just started off with a conversation, right? I reached out to you because I'm really excited about this. You know, ASUS has always been somebody that's at the forefront of performance innovation and design and supporting the latest generation standards. So, you know, we were at the beginning when the first SATA 6G implementations came to the market. We were at the beginning for first USB 3, USB 3.1, Thunderbolt, and so many other, storage-related technologies. And when Intel first kind of came to us, that they were really looking to kind of set a new precedence and push forward with NVMe, which is the standard in terms of the protocol and the interface that helps to replace the current AHCI protocol. We were like, 100%, we want to be part of that. We want to work with you to help to make sure that we can have a 100% ready solution with you guys providing all the awesome work that you guys are doing in terms of the controller, the high quality validation, the NAND, all that great stuff that you're bringing to the table. And then we can bring our expertise, of course, in motherboard design, the interoperability and the validation and all the work that we're going to need to do to be able to make this seamlessly handshake to bring you ultimately a combination of course, having the motherboards that support these awesome SSD solutions that Intel's going to have available, not only with the 2.5-inch version, but also with the PCI Express add-in card version. So that's pretty much where it does.
Intel wanted to work with a established, reputable, top-tier board manufacturer like ASUS to make sure that everything worked together.
Yeah.
And like you said, testing validation, because there's lots of different possible scenarios, configurations that this drive might be set up in. But let's talk some headlines for right now, because if you guys are into SSDs and you know what SSD specs typically are, especially if you're accustomed to SATA Rev 3 SSDs and those specs, the specs on these will blow you away. We already mentioned 2.4 gigabytes per second reads.
That's correct, yeah.
Writes are about in the 1.2 gigabytes per second range.
Correct, yeah. And even those actually specifications, to be honest, they're a bit conservative. When Intel was actually doing the initial kind of validation and the performance analysis testing, it was still with early generation firmware that hadn't 100% been finalized and fine-tuned. And at this point, you're definitely seeing that actually in real-world testing and synthetics, we're actually getting over those markers.
So it's kind of a lowball number, actually.
Yeah, let's say it's a conservative number. So you actually, I wouldn't be surprised to see even greater levels of performance. In some of the already testing that we've seen, we actually were getting 2.5, 2.6, 2.7 gigs worth of read throughput. On the right side, 1.3, almost 1.4. You're just talking about utterly monster numbers. And keep in mind that the really exciting thing is that this is leveraging 18-channel flash architecture, right, that they have in here that comes from their data center, their enterprise series based SSDs. So you have an impressive level of performance that they're bringing to the table with it being a native NVMe controller, which is the other big point.
Okay.
I mean, historically, every SSD we've been looking at has been limited by the HCI, that HCI protocol and interface that is on your traditional SSD. So, the highest numbers you could see is going to be, 500, 525, maybe 550 megabytes. And then the only way we can get higher than that would be through some form of RAID combination, which in itself doesn't always offer perfect scaling.
So NVMe kind of leaves behind all of the trappings and hurdles that you had to run through that were really established for mechanical spinning hard drives and that sort of thing. It's an older standard.
It's actually very long in the tooth. We're talking about, at this point, over 10 years.
That's a long time.
So especially with everything advancing, it's crazy that we're still using essentially this older mechanism, which still can offer us great performance. I mean, the best SSDs on the market are still using HCI. So it's not like it's a bad specification. It's just not purpose built for flash. Okay. But I think before we jump into that, getting back to what you were talking about, we got those really big halo points. Yeah. So, it's a PCI Express Gen 3 by 4 interface.
Okay.
So that's in itself is crazy.
Massive bandwidth. And by the way, what I keep picking up and holding because I think it's fantastic is this little drive here, which is the 750 series 2.5 inch version. It's thick. It's 15 millimeters thick, but this is a 2.5 inch drive.
Yep.
This is also available in direct PCI Express trim. This is going to actually interface in a really unique way via M.2, and we're going to show you guys how this one works. There's another one in the system that JJ has over here, which is just direct PCI Express, which might be a little bit simpler if you don't have M.2.
Correct.
But we're also going to go over everything you need to actually
make either one of these solutions work
and plug it in and work, because there are some requirements there. But I want to keep hitting these halo points. We're talking about input-output operations per second.
Yeah, so these are just monster numbers. When you talk about the read, once again, conservatively, you're talking about 440K. So that's just insane. I mean, when you take a look at even high-performance, generally RAID configurations, you're talking about 100K, 125K, maybe 200K, right? But here you're talking 440K, and once again, in some of the real-world testing that we're getting at this point with the final firmware in place, we're seeing an excess easily of 450K in terms of the read. On the right side, you know, conservative again, about 290K.
Okay.
You could even be looking beyond that. So just overall, truly monster numbers. And then latency performance also, which isn't a measurement that's usually kind of associated with SSDs, it's significantly brought down as well. So you're going to get huge improvements in that regard. We've also got, you know, power loss protection that's built into this unit as well. So you get, you know, that safeguard in terms of having not only big capacity with great performance and that ultra high throughput, but you also have a safeguard mechanism that's built in there. And rounding it all out, you got awesome performance consistency that bringing over from the data center environment to help to make sure that as you full this drive, you know, and you're utilizing it over time, you're going to help to maintain that high level of performance.
So even if you've got 70-80% of the capacity used, you're not going to have any slowdown in performance.
You can still get a really ensured level of consistent performance, which is really important because performance consistency sometimes isn't realized by users, that as they fill their drives over time, if they're not necessarily have a controller and a firmware architecture that's purpose-built to maintain that performance, you have to generally over-provision a drive. So you could sometimes take 10, 15, 20% of your drive and you're losing that. While here, definitely this is going to be a premium drive, but at that same time, you won't have to worry about over-provisioning. You'll be able to maintain a lot of that performance that this drive is purpose-built for.
Okay, so those are kind of the Halo talking points for you guys. And if you're not impressed yet, you probably don't get excited about SSDs, and that's okay. Not everyone necessarily geeks out about this type of subject.
Fully bootable.
Oh, fully bootable, yes, and that's the last thing. So yes, you can take this, plug it into your computer if you have the right hardware right now, and you can boot directly off of it, which is a limitation often when you're talking about especially a new protocol like this and a brand new drive. Sometimes it's more limited in its actual application. But I really like that Intel and working with ASUS has done as much as they have to make this drive as usable as it is. Granted, there are some interesting ways that we're going to connect it. I think you guys are going to like it though, because it's pretty kind of mad scientist-y, I feel like.
It's pretty cool.
Like JJ was explaining to me, like they've done some stuff that's a little bit out of spec, but it was just to say, like, hey, we have all this technology right now. How can we kind of put this all together to give consumers a drive that just blows away their expectations when it comes to performance, but is also usable and functional for what you might want to use it for. So guys, I'm going to be doing a little bit of on-the-fly B-rolling for you because we're shooting this the day before launch, and I want to post this tomorrow. So forgive me if it's a little rough around the edges, but I wanted to give you guys some closer looks here. So JJ, let's start off talking about compatibility. If somebody is watching this video and they're like, this is the best thing ever and I want it now, what do they need other than presumably at least an ASUS X99 Sabertooth motherboard?
Okay, so that's an awesome question. It's a little bit loaded. So first and foremost, remember, one of the big things that we pointed out originally is that this is a purpose-built solution for the highest level of performance. So it's PCI Gen 3 by 4 in terms of the requirement to be able to maximize that performance. So as you know, right now with the Z97-based platform, it's an awesome chipset, great CPU, but we are a little bit limited in terms of the total number of PCIe lanes. So optimally, most users that are on the X99 chipset are going to be the most suited to probably be able to enable this solution, just because of the number of PCI Express lanes that they have available to them. So in terms of compatibility, the Sabertooth X99, which is literally going to be shipping and made available almost in lockstep with the availability of the Intel 750 series, whether it's the add-in card or the 2.5-inch version, will have a shipping UEFI that is NVMe ready. Now, this is extremely important. Without the UEFI, you will not have the ability to correctly have these drives work in their complete and normal functionality, whether it's from a post and boot functionality as well as from a performance standpoint. So you do want to make sure to have an ASUS board that has that UEFI in place to be able to ensure that best-in-class interoperability, compatibility, and performance. Now, the Z97 series of motherboards, we have already all released UEFI in place to give them full NVMe support.
Okay.
So if you want to drop in the PCI Express card, you're going to be good to go. 100%, you'll get all that performance that we talked about along with all the features of that drive. But keep in mind that you're going to need to do it in probably like the second PCI by 16 slot. Okay. So if you're somebody that was targeting maybe possibly like an SLI configuration, you would be essentially eliminating that possibility because you're going to need to go directly in that option. Now, some of the motherboards, if you look in the detailed manual information, will generally tell you if maybe like the third PCI slot will be accessing CPU lanes from, Gen 3 lanes from the CPU. Okay. But traditionally, usually third slots on Z97 boards will usually be connected to the PCH. So since the PCH is far more limited in terms of its PCI lane connectivity because it does it through the PCH's lanes that are enabled, which are only Gen 2, you're going to have a lot lower throughput. Okay. Now, this drive, because it's native NVMe architecture, because it's more efficient, because it offers reduced latency, higher parallelism, and just a huge amount of improvements in terms of the command chain, even at operating at a slower performance, will give you a better experience than you would have from a traditional SSD or a traditional RAID configuration with normal AHCI-based SSDs.
But I don't want better, JJ. I want the best.
You want the best. So for people that want the best, that's where the X99 solution will come into play. Okay. So with X99, far less to worry about. If you drop in the add-in card because you've got tons of extra lanes, you can probably drop it into the third slot and still have your SLI configuration and you're rocking and rolling and you're good to go. But always make sure that the slot that you're using can leverage CPU lanes as opposed to lanes that would be, let's say, provided by your PCH or that are Gen 2 enabled. Now, where things get interesting is what we've talked about in the HyperKit module. So I don't know if maybe we want to reference that guy, but this is where things become a little bit more interesting. So when Intel...
But just to sum up so far, we're talking X99 from ASUS.
Yes.
And we're talking Z97 from ASUS. Yeah. And then maybe you guys are working on other stuff. I don't know. I know you didn't say this, but just for anyone who's curious, maybe Z87. We don't want to talk about that too much yet. But...
Yeah, we are going to be working. Technically, it shouldn't be an issue to enable the add-in card support. Okay. Of course, you have far less solutions on that are M.2 based. Traditionally on Z87 because mSATA was still kind of in trend. That's what you saw on more Z87 boards. So pretty much on Z87, it'll be the focus at getting NVMe support. Hopefully, along with X79, no guarantees as of yet. We'll project those timelines later out. Okay. But right now, if you want it, Z97, X99 for sure.
Okay, and then I asked JJ earlier about AMD side as well, and just long story short there, keep your eyes on the ASUS PC DIY website. Right. They'll be posting updates as they're available. Again, that's sort of a maybe wait and see kind of situation.
Right, okay. And of course, definitely with Intel, they're right now on both the mainstream chipset as well as the ultra high-end enthusiast chipset, they have native Gen 3 support where that's not necessarily the case on the AMD side.
So I got some, and then of course you want to be plugging in, if you're using that PCI, into a PCI slot that's giving you a direct connection to the CPU and nothing that's going through the PCH or something like that.
Correct.
Now, if you don't want to use that PCI slot though, and we've already been showing off the 2.5-inch drive, we have a 2.5-inch drive, we have a connector on it that you guys have probably never seen before.
Yep.
It's very, well, it's not that different from like a SAS connector maybe. Just visually.
I'd say SATA Express.
SATA Express?
It looks kind of like a SATA Express connection.
But what this connector does is it actually allows the drive to connect to an M.2 port.
Yes,
and they're using this, what is this little device called?
So that is called our HyperKit. So that's a special module that we designed and developed to essentially allow you to interface with this SF8639 connector to what pretty much looks like a mini SAS type connector. It's already been used in the data center environment, but that's essentially what we have at play. So we'll have a cable that will, a cable that's already included with this drive that will allow you to go ahead and connect the HyperKit to this, and then that interfaces in with the X99 board and is able to leverage the PCI Gen 3x4 interface.
And when I was talking about mad scientist-y stuff earlier, this is kind of what I was talking about, because you have one connector here, another connector there, but it's allowing you to make use of the M.2 slot in the motherboard. And then you have this little guy here, this little cable, right?
Yep.
And then this connector type. What was this actual plug called again?
So that's you can call it a mini SAS interface, yeah. And then the other end is your SF 8639 base connection.
8639.
Yep.
And then that plugs into the drive, right? Just like so. And then it's got another little lead coming off of it with the SATA plug, so you can get extra power to the drive.
Yeah, that is required because, of course, this only handles essentially all the data. So this is required to initialize and actually have the drive correctly work.
So you plug that in, and then you just run that over to your motherboard. And as you can see, or maybe you can see when I cut it in the future, it plugs into the M.2, and then your drive is connected.
Yep, you're 100%, and you have full 100% PCI Gen 3 by 4 base performance for that 2.5-inch drive.
And like the performance from the 2.5-inch is it's going to be the same, right?
It's the same
as the PCI
exactly.
Express.
It's the same exact thing. So you have no compromise in that performance. And the great thing is also, if you guys are kind of wondering, is part of the reason why Intel wanted to have this type of flexibility and support with this type of drive too, is that while X99 is purpose built for this, ASUS may be coming to the market at a later time frame with smaller form factor X99 solutions, where if you have more restrictions on the number of PCIe slots that you physically have, this allows you to have smaller form factor systems where you might not be able to use a PCI Express add-in card, but you still want to have this amazing high performance. Or even if you guys might be aware, like our Z97 Maximum 7 Impact, that actually has a by 4 Gen 3 PCI M.2 base interface
on the back.
Yeah, so you could interface this guy into that Impact board and have that primary graphics card installed, right? So no room for an add-in card, but you could still have this ultra high level of performance enabled to you on something like a mini ITX board.
Now, just from a practical perspective, this is a bit higher than a typical M.2 drive, so bear that in mind when it comes to compatibility with graphics cards or that sort of thing. But I really love this type of innovation and the way that you guys have just like you fit it in there and it friggin' works. So that's really cool. So that's essentially all you need right now if you want to use this drive.
Yeah, there'll be a little really actually everything has been, because there's a driver that's built into this because it's a native UEFI based device, which that's another little caveat, is this only supports native UEFI based installations, which that's okay, because if you're probably building into this system, you've got a UEFI compliant motherboard like an ASUS board, graphics card, optical driver if you're still using that, and of course this, and ideally you want to be utilizing with the Windows 8.1 operating system to be able to make sure that you have the continuity and consistency to have everything seamlessly work. But there's nothing that you need to do. It's pretty much transparent and seamless, like you would use a traditional SATA-based SSD that's using the HCI protocol. You're good to go. Now there's a couple little parameters in the UEFI that if you want to tweak it for the best post and boot performance, you can go ahead and tweak those, and maybe we'll show you those guys. But beyond that, not too much to do. It's a pretty straightforward process.
I'm still trying to figure out what your reference was to a micro ATX ASUS X99 board, but yes, let's take a look at that, JJ. Okay, JJ. So we're now in the UEFI of the X99 Sabertooth, Sabertooth X99, and so we're gonna do a quick little what we're talking about, optimization for NVMe drives.
Yeah, this is pretty much just the way to optimize your UEFI to make sure that it's going to have the most effective post and boot time, and this would actually also be recommended for any current HCI based drive that is UEFI compliant. Okay. So pretty straightforward. All we're going to need to do is move over into the boot, and from there we're just going to want to set the drive to hard drive only. Essentially, we can just have it boot drive only because we only want to boot just that one single volume. You want to disable essentially all polling for USB support. This doesn't mean it disables any USB ports. They're just not pulled at the beginning of the UEFI being initialized. We want to go ahead and have the next boot after power loss set to a fast boot. We want to eliminate any set post time delay, so set that to 0 seconds. And then probably one of the most important parts is here we want to go to CSM compatibility support. I'm not going to get into this. This is a very complicated topic, but essentially it just means that it's acknowledging that the board only has the latest generation type of hardware that supports UEFI. And what we want to do is, if we have it, it'll look something like this. You can manually set everyone to UEFI only, which would be an option. But you can also just go ahead and bypass all that and just disable any type of CSM support. So essentially any legacy support. And once you've gone ahead and done that, you'll pretty much be set. At that point, you can hit F10 and you will have the most optimized parameters to have the fastest post and fastest boot. Now, for users that are utilizing the HyperKit, there will be one thing that you would want to jump into, which is you would want to go into that PCH storage configuration, select that, and hit enable to the HyperKit support. And beyond that, you would just go ahead and F10 and you'd be good to go. So
beautiful.
That's it.
And that's how you turn on the HyperKit mode, specifically if you're using one of these with the HyperKit.
That's it.
Okay. Next up, we're going to jump into the operating system, and we wanted to show you guys some performance numbers, just in case you didn't believe us earlier, and then also maybe like some real-world
Yeah, a little
kind
bit of
application
some
type stuff.
performance workflow example.
So let's talk about while we're waiting for the boot. Never mind, it's already booted up. Let's talk about who this drive is built for, right? Because we were just discussing this. We might as well continue discussing it.
Pretty much, I think the easiest way to look at it is if you're somebody that was already going to be making an investment in the best SSDs that were on the market, and you were definitely looking at RAID type configurations, this is a solution for you. Regardless of whether you're into gaming, whether you're into content creation, whether you're into computation or analysis, or any other kind of varied workflow, it is pretty much just a better option than you doing any type of RAID.
JJ was suggesting that gamers would want this drive, like especially maybe the 400 gig one, which is a little bit more cost effective. And I was starting to argue with him, like, JJ, gamers don't need that. And he kind of argued against me and then changed my mind, which JJ is very good at doing. So I'm going to leave this question to you guys. Gamers out there who are currently gaming, especially if you're already gaming on an SSD, would you be interested in, say, a 400 gig version of this drive if it could make a significant impact on game load times, and especially things like little stutters and hiccups that you might get in game from having to pull stuff off the disk? Let us know down in the comment section below. But for now, we have CrystalDiskMark.
Yeah, now
this is special CrystalDiskMark.
Yes, correct.
Okay.
And you will be actually able to download this version directly from the website, but this is an important point, and actually we talked about this a little bit before. NVMe actually requires a new form of software to really be able to acknowledge how it can work and how it can maximize the throughput that it has available to it, especially when you benchmark it, because traditional based benchmark applications are really designed for HCI based drives, so they can't really saturate the drive correctly in terms of showing us the full real throughput. So if you want to benchmark this type of solution, you want to have optimally either something like IOmeter, where Intel will be working to release a guide to show you how to correctly tune it, so that if you want to benchmark an NVMe solution, you can use that. Or if you want a little bit more simple solution, CrystalDiskMark has already worked directly with Intel, and Intel's worked with them to be able to fine tune their application to have it be updated to be able to benchmark correctly.
Okay.
Yeah. So from here, pretty much all we want to do is we're going to leave it set to 3 in terms of that, just to give us a little bit less variability in terms of the performance set. We'll go ahead and set it to 4 gigabytes in terms of what we have there, and we'll go ahead and let it run through its performance. So keep in mind that, of course, the highest level of performance would come from this drive, of course, being a standalone, let's say, a storage volume, as opposed to running the operating system. Operating system is always going to take a little bit of overhead, but one of the great things that you have inherently with this is that there's significantly reduced overhead because it's NVMe. There's a lot less things in that whole chain as far as storage that the NAND controller and then from there the operating system have to work through to be able to give us better performance. So that's one great aspect of that. One other key point too is you want to make sure that the NVMe driver is installed, to be able to ensure that you get the best performance. Now, it's not required for it to work, and you'll still get great performance, but you'll have significantly reduced performance numbers without the NVMe driver installed.
And where would that just be available directly from Microsoft?
No, that's actually NVMe driver is directly supplied by Intel.
Oh, directly from Intel. Okay.
Yep. So it pretty much will come available with your drive. So you can see right here, we've already reached 2.7 gigs and then 1.3 gigs on the right. So utterly just monster performance. And if you remember when we initially talked at the inception of this video, we said the number was actually what? It was
2.5.
2.4.
Or 2.4 even.
is the rated specification. So you're getting an extra 300 megabytes. That's already...
That's for free.
Yeah, that's for free because Intel...
Act now. Order today. You get an extra 300 megabytes per second.
Has already done...
That's like 300 megabytes per second, like 3-4 years ago. That's like the fastest performing SSD.
You could,
maybe a little bit higher than 300, but yeah, let me go back to like a C300
it was a little bit faster than that, but think about it like this from perspective. If somebody all of a sudden just gave you 300 megabytes for free on a current SATA 6G SSD, and it went from 500 megabytes to working at 800 megabytes, you would be doing backflips.
You'd be pretty excited.
Right? So the fact that you just kind of get it for free, and the fact that Intel has been able to refine and make improvements to the firmware and even have it operate more effectively is fantastic. And, this also gets to another point. As it's finishing off these numbers, you can just see that, across the different types of loads that we have here, we're just getting some insane speeds. But performance consistency is another really big hallmark of this drive, and something where that also gets back to when we talked a little bit about different usage models. That helps to ensure that the performance that you have is maintained throughout the entirety of the drive, which is really important, because if I start off having really fast load times, or I have really fast installation times, or I have fast and responsive experience for my system, I don't want that to grade as I'm filling the drive up more and more, which is something that people on mechanical hard drives, you never really thought about, right? Because more or less the drive's kind of performance was pretty much the same, more or less.
Yeah.
But on an SSD, that's actually not the case. As you fill it up with a lot of different types of traditional SSDs that don't have targeted performance consistency built into their firmware and how they're designed, you can have actually a lot of performance that the only way to compensate for it would be over provisioning. But we can see overall, this is a quick just synthetic wrap up, but just pretty insane numbers.
Yeah, that's really impressive all around. And again, guys, remember, if you get this drive, don't do the normal version of CrystalDiskMark.
Yes.
You need the special version that's NVMe compatible.
Yeah, and pretty much there's no other traditional benchmarks that are out right now that are really suited for in terms of pure synthetic testing. Okay. So if you're like an advocate of ADO and stuff like that, hopefully with time you'll see updates to that. But right now it's pretty much IOmeter and
it hasn't been updated since like 2010 or something. Yeah. I feel like. It's like, oh, storage never changes. All right, but here's our numbers there, guys. 2,700 megabytes per second reads, 1,300 megabytes per second writes. The 4K QDepth 32 numbers are also quite impressive. All right, one last demonstration that JJ has set up, and this is just a video that we're going to play back for you guys, but it's a demonstration of this drive in action, specifically using Adobe SpeedGrade.
Yeah, so pretty much what we kind of did here was we took essentially a 4K file and input it into Adobe SpeedGrade, and what we're essentially allowing you to do is see what would be the kind of restrictions that you would have if you use the traditional very high speed SSD. So we use the Intel 730 series SSD, which is nothing to snuff at. I mean, it's a very high quality, high performance SATA 60 SSD, but it could really barely sustain being able to do color grading on one single 4K video frame. And ultimately what we're able to show you is that we could not only do 2, but even actually go to the point of doing 3, which is really the way you would want to have it work when you're doing actually color grading and lighting grading, because you want to be able to see those 2 different sources at the same time, right?
And you want to be able to scrub.
Yes.
Being able to scrub while you're video editing is like so important, and that's why I love really fast SSDs to store my actual footage on that I'm editing off of. So this demonstration, again, just simply put, it's going to show 3 4K images that are all up on the screen at the same time. They're being scrubbed through to do color correction and to match them and to show that, frame A on this side.
Right, and there's also going to be fraps running that actually shows you the frame rate.
Okay.
And so you want, of course, ideally have that frame rate not really drop, because that helps to maintain the fluidity of the workflow as you're actually in the editor or you're in the color grader. And I think that both of us can agree that regardless of how you feel about maybe different aspects of enthusiast usage, that this is one of the really key areas that for content creators, professional rendering applications, for anything like that, this is where you really see this solution just coming into its own and offering just an awesome level of performance.
Yeah, this was the thing that JJ showed me where I was like, I need one. I need one. I don't edit in 4K. I really don't. I can shoot 4K. My LX100 does 4K, but I don't shoot in it very often because, setting up the whole workflow, storage space, all that good stuff that you need for it becomes a lot more. It's 4 times as difficult, so to speak, as 1080 recording. So being able to do this 3 4K streams off of one drive. That's one drive. Can you raid these together, JJ?
Not
yet.
Yeah.
That's obviously probably going to be the next question. How many of these can we then wedge together to make some crazy thing like that? But who knows?
But even keep in mind that even if you were to do 4 SSDs in a RAID, you couldn't equal these numbers. You'd have to do it through some form of specialized add-in controller card, because the DMI link that exists on the PCH is saturated at about 1.5 gigs, so it's impossible. And on top of that, you would also run into controller issues. It would be less efficiency. You'd have more overhead, because this drive, 18 channels of flash with that custom NAND controller, it's purpose-built to offer this speed versus what you would traditionally have with normal SSDs, where they're essentially, you're trying to scale them into offering that peak performance, and there's a lot of other little pieces in the pie that affect the overall experience.
All right. Well, guys, that I think is going to wrap up this video. Thank you for sticking with us. I know it's been a long one, but we wanted to share this information with you. JJ, thank you so much for stopping by.
Awesome to be here for the first time.
JJ just hit me up. He called me yesterday. He's like, I'm going to be in town. Do you want to do this? And I was like, yes. Come here, let's talk about this. So guys, once again, this is the Intel SSD 750 series. It's available in the 2.5-inch trim like this one. It's available as a PCI Express drive, available at 1.2 terabyte capacity and 400 gig capacity. And there's going to be an 800 gig one as well.
Coming out a little
bit
later.
In the future. So check it out. It should be available now on the links down in the description down there. While you're down there, hit the like button. Let JJ know that you appreciate him coming by and sharing all this info. And thanks for watching.
Yeah, and if
watch JJ's stuff too.
Yeah, thank you.
ASUS
And if
PC
you have any questions on any of the ASUS points or any other things like that, I'll be watching this thread, so I'll definitely try to come back and answer in the comments. But you can also make sure to check me out at pcdiy.asus.com.
Beautiful. Thanks so much for watching, guys, and we'll see you all in the next video. Hello, everyone, and welcome to... Wow, I almost said welcome to New Activity. Wow. It's just being here with JJ. It's
I'm
like
sorry.
old
I'm
times.
messing
Like
it
old
up.
times.
Like old times.